In this video, I want to introduce you to the basics of dimensioning architectural drawings. So on your monitor right now, you're seeing a floor plan, and the dimensions that you see are these lines and numbers that are in red, and they tell us the location of features of this floor plan. And we have dimensions on the interior of our floor plan and dimensions on the exterior of the floor plan. The dimensions we're seeing right here across this interior are locating the centers of these windows. And so there's a window here. It's 3 feet wide by 4 feet tall, and it's located 2 feet 4 from its center from the outside edge of the frame of this building. And then we have from the center of this window to the center of this window, we have 3 feet 6. All right, so I'm going to get into this a little bit now. And so whenever we're dimensioning floor plans, what usually happens is that the designer, who may be an architect, will turn over the job of drawing the floor plans and the elevations and things to drafters. And drafters are responsible for adding the dimensions to the floor plans, to the elevations, and to other construction details. So just like with mechanical drawing, it's the responsibility of the drafter to accurately transfer the dimensions from the designer's input to the finished drawing. A mistake on an architectural drawing, like a mistake in a dimension, could lead to a costly revision on a construction site, or in some cases, like the worst case probably, the failure of a structural system. So it's very important that drafters follow the exact inputs given to them by the designer. So as with mechanical drawings, there are some standards that apply to the creation of architectural drawings. And often in an architectural office, rather than having a formal standard that was produced by an outside agency, they may have an in-house drafting manual that was developed by their own designers and architects and drafters. And this manual is used to guide the placement and spacing of dimensions, text height for dimensions and notes, and naming conventions for title block on the title block and also on layers. But there is a national standard called the National CAD Standard, which we call the NCS, and increasingly a lot of architectural design firms and a lot of agencies are adopting the National CAD Standard. If you go to the National CAD Standard website, in fact, there's a link to the adopters, and you can see all the organizations that are currently using the National CAD Standard in the production of construction drawings for those organizations. So the NCS was developed by experts from the field of architecture and engineering and construction, and the attempt was to standardize building design data and improve communication among owners, designers, and construction professionals. The goal of all standards really is to make the drawings clearer and to reduce the number of mistakes that might be made by drawings that don't comply to a standard. The NCS defines standards for drafting conventions, CAD layer naming conventions, which are based on the AIA, the American Institute of Architects CAD layering guidelines. It defines standards for dimensioning, drawing sheets, schedules, drawing sets, terms and abbreviations, graphic symbols, notations, and plotting. If you'd like to know more about the National CAD Standard, you can go to nationalcadstandard.org, and you can download the National CAD Standard from their site if you have a credit card. And the standard changes not every year, but there are different versions of the standard, so you would want to purchase the latest standard if you were doing this. So another term we need to talk about is a term called BIM, which stands for Building Information Modeling. So another paradigm in design and construction is BIM, which amounts to a move away from two-dimensional drawings that do not have intelligence built into them toward a linked database that all the users of the system can tap into. So what we mean by that is, rather than just having a two-dimensional drawing that is just made of lines and symbols and text, we start by creating a three-dimensional model in most cases, and we build all the intelligence into the model. So for example, the way we modeled the building is where we'll pull the dimensions for that building from. And BIM is sort of the wave of the future, and there's actually the National Institute for Building Sciences. They are working on standards for a BIM, the movement into BIM. And so you may come across that. AutoCAD is used a lot when we draw two-dimensional drawings that don't have intelligence built into them. Another Autodesk product that's used now is called Revit, and Revit allows you to create buildings that have intelligence, and by that I mean you can actually derive dimensions and things from the database of a Revit model. All right, so architectural designers, whether they're architects or just designers, determine the dimensions and notes that will go into the design of a building. And they use this to create design input. And so this could be a sketch showing the drafter the placement of walls, doors, windows, other features. And drafters will use the design input to draw the building's features and add dimensions and notes as necessary to build the project. So especially in the residential framing area, if you understand something about framing of a building, it's very helpful because the location of features like doors and windows really depends on the framing. And so one of the standards is, generally speaking, is to place the framing studs, these vertical members that you see right here, 16 inches on center. And but when you get to a door or a window, you can see there's some extra framing involved in that. And so when we dimension to doors and windows, generally what we do is we dimension to the center of the door or the window, and then we tell the size of the door or window. And that allows the people that frame this, the carpenters or whomever, to take into consideration how wide what we call the rough opening needs to be for the window or the door so that they can fit the door or window that has been specified for this project. So we can see these rough opening for a door, rough opening for a window, and the next thing I want to show you is a table that gives you an idea of the size of a rough opening. So let's say that this door is a 3.0 door, which is a 3-foot wide door. So if we come down right here in our table, if we have a door that's 36 inches wide by 80 inches tall, now that's the actual size of the door itself, we will have to frame that with a rough opening 38.5 inches wide. So you can see it's 2.5 inches wider than the width of the door. And the rough opening for the height, which would be from here down to the floor, would measure 82 inches, even though the door itself is 80 inches. And that's because generally doors come what we call pre-hung, so they have a frame around them. And the frame adds that extra bit of, couple of inches around a door. And we have to make sure that the rough opening will allow for the frame to fit inside there. And the same is true with windows. We're gonna frame that window wider than the actual size of the window just to ensure that the window will fit. And then we can come in and we can shim around the edges of the window to make sure we get a tight fit or whatever it takes. But that's what we mean when we talk about a rough opening for a door or a window. So here's an example of an interior view of a little cottage that's being framed, and you can see how many 2x4 framing members it takes between two windows that are close together. It actually takes 4 2x4s to frame between two windows. And if those 2x4s are 1.5 inches wide, if each one is 1.5 inches wide, that would mean we have to have at least 6 inches between two windows. So when we dimension this, if we're dimensioning from the center, we have to take into consideration the rough opening width of the window and take half of that, and then we also have to add into that enough framing so that we have enough of allowance between our windows. And the same is true over here. We would dimension to the center of the door, and then to the center of the window, and to the center of this window here, and then over to the edge of the wall, for example. All right. Now, another thing you have to keep in mind when you're framing and you're looking at things like this is, if this is the front door for this building, when you walk in the front door here, what would be right here on the left of this door? Well, it would be electrical switches, probably for a porch light and maybe for an overhead light that might be in this room, or a ceiling fan or something like that. And so if you're the designer, you want to take into account that you have enough room to mount all of those electrical switches. And remember, each of those switches will have an electrical box attached to it. So the switch itself is housed inside an electrical box that has to fit between these 2x4s in here. And so a designer has to take that into consideration when they figure how many switches they will need, because you don't want the electrician calling you from the job and saying, hey, I don't have enough room to fit all those electrical boxes in this wall the way that you drew this plan. All right. So again, these are things that as you design, you want to think about. And of course, you don't know what you don't know yet. So some of these lessons are learned the hard way. But one thing I always recommend to students is that maybe you take a course in framing and just basic construction, so you sort of understand the way that this thing will be built, the way these buildings will go together, and that will help you with your dimensioning. So here's an exterior view of the door and the windows that we're seeing right here. And just to give you an idea, this silvery looking material that's on the outside of this is called a radiant barrier. And that actually reflects some of the sun energy that comes in here and helps keep this building a little bit cooler. And the porch has been poured, that's concrete right there, but rather than being blocks, even though you can kind of see the lines in this thing, there's some lines running across here, this is called stamped concrete. So a pattern was stamped into this concrete while the concrete was still wet, so that it resembles blocks, but it keeps the cost down of doing that. So when we're dimensioning, there are really two types of dimensions, just like there are in mechanical. There are size dimensions. So for example, we have a porch. There's a porch step right here. There's a step here and a step here. And the steps up to the porch are 8 feet, 8 inches wide. But the distance from the side of the porch all the way across the porch in this direction right here, the porch is 12 feet wide. So these are examples of size dimensions. And this little cabin, the total width of the cabin is 24 feet, 0 inches. All right. Now, let's look at these dimensions here. We have a window. This is our window right here. And it's 2 feet, 8 inches wide. It's a 2.8 by 3.0. 3.0 means how tall the window is, which we can't see in the floor plan, but we can see that in the elevation. It's 3 feet, 0 inches tall, 2 feet 8 by 3 feet 0. All right. The center of that window, if we measure from the framing right here, is 6 feet, 1 1/2 inches to the center. And then from the framing on this side to the center of that window is 5 feet, 10 1/2 inches. So that's an example of a location dimension versus a size dimension. Up here, we also have some location dimensions. The distance from the center of this window to the center of this window is 3 feet 6. And from the center of this window to the center of this door is 4 feet 2. So that is a location dimension. Right here, it's kind of hard to see, but it says 3.0. This is a 3.0 door, which means it's 3 feet wide from side to side. And this is the door swing. This is the symbol for a door. And the hinge would be on this side, and we actually call that the hinge jamb over here on this side. And jamb is spelled J-A-M-B, hinge jamb. The opposite side over here is also a door jamb, And we call this the strike jamb, and that's where the lock and the door hardware would be, is over here on this side. So we have the strike jamb on the left in this case, and the hinge jamb on the right. So architectural dimensioning conventions, we'll talk about these. First thing is, what do you do about tolerances on an architectural drawing? Well, you'll never have the super tight tolerances that you have on a machine design, right? Where you have, you know, 1/100th of an inch or 10/1000ths of an inch, something like that. Generally, what you're going to have is probably not much closer than 1/4 of an inch in terms of how you're going to be dimensioning things. Now, that may not be true on a commercial building where they can control things a lot tighter than they can when they're framing with lumber. But on residential construction, I would say 1/4 of an inch is probably as tight as you are going to have to get things anyway. The other thing that's a difference between the way we dimension architectural and mechanical is instead of having an arrow, so instead of having an arrow where the dimension ends, we might instead have a slash mark like that. And we call these slashes where the dimensions intersect. AutoCAD anyway calls those tick marks. Okay, and so when you're setting up your dimension style, you actually want to control the size of the tick mark. Now, the National CAD Standard says that we can have tick marks or we can have arrowheads. Either one is acceptable under the National CAD Standard. Usually when we're framing, we want to go from the edge of a framed wall like this to the centers of other walls and partitions. So we're going to dimension from an exterior wall face to face to stud walls or masonry units. It's not a good idea generally to dimension if we had brick out here on the side of this or stone. It's not a good idea to dimension from brick and stone because it's too irregular. So instead we would dimension to the inside where the framed wall begins, because that's more, you know, it's more standard in size than stone or brick, and gives us a more accurate dimension, okay, because it's finished lumber. Okay, so like I said, dimension to the centers of openings. The standard, the NCS standard, says that dimension should not be given in increments less than 1/16 of an inch. And but as I said, on a residential plan where you're framing in lumber, that would probably be tighter than what you would generally need. Okay, so on this one you can see that dimensions are given from the outside edges of frame walls to the centers of things. I've already mentioned that. And unlike mechanical drawings, these chains of dimensions, so we have a dimension here, and then that's added to a dimension here, and added to a dimension here, and then you have an overall. In a mechanical drawing, we'd be worried about the tolerance applied to this, plus or minus the tolerance applied to this, plus or minus the tolerance applied to that, and how that may affect this down here. There's less concern of that for certain in an architectural drawing and in construction. All right, so dimensions and notations are also added to elevation drawings. So this is an example of a front elevation of a cabin and the side elevation, and it's actually the cabin that we see right here, and this is the front. You see these windows here and this door. Those line up with the window here and the window here and the door here. But we also can add a lot of notation and dimensional information to our elevations as well. And so we can see a dimension right here. The roof overhang right there says 1 foot 6 inches. And the roof overhang right here is 1 foot 0 inches. We see that right here. And then we also have notations telling us what the siding is, the cedar V siding. We have our roof slope symbols, and so that may look something like this. And so what that means is that for every 12 inches that roof runs horizontally, it rises 10 inches. So if you connect the dots, that is the pitch of your roof, of the rafters of your roof. So we would say this is a 10-12 pitch over here. This is a 10-12 on this side, but then the pitch changes right here to a 4-12. There's other notations on here about the chimney and about some 6-inch galvanized iron flashing, which is an attempt to waterproof where the chimney meets the roof and some things like that. So generally these kinds of notations would be on the sketches that you would receive from the designers or the other inputs that you get from the designers, and you need to make sure as the drafter that you get all those dimensions in there. Okay. So the alignment of text, your text can face the bottom like this does, or it can face the right. So when you have vertical dimensions, they should face the right, and when you have horizontal dimensions, they will face the bottom of your sheet. And that's true even on dimensions that are on the interior of your house. You don't want some to face the left and some to face the right. They should all face to the right. The National CAD Standard specifies that the text used on architectural drawings should be sans serif, which means without the little marks. So let's see, I'm going to make a 3 over here. If you had those little marks on there like that, those are serifs. Okay. The National CAD Standard says you should use a Gothic style of font. So you could use Arial or Tahoma or something like that. But a lot of offices where they do residential design and stuff, the standard that they may use in an office may be this architectural style of lettering that looks almost like freehand lettering, like back in the old day, because architects want their drawings to have that artistic look. But the NCS, you take some of that out of it when you're using the NCS, because you want to you're going for clarity rather than for an aesthetic look in your drawing. So the minimum text height according to the NCS should not be less than 3/32 of an inch when the drawing is printed. And so that would be 2.5 millimeters if you're in the metric system. And it also says all notation should be capitalized, italicized, underlined, or bold fonts should be avoided. All right. So AutoCAD comes with several architectural style fonts which resemble hand lettering, and one of those is Stylus BT, this guy right here. You may also have City Blueprint and Country Blueprint loaded in your fonts when you're creating that. But again, that would not comply with the National CAD Standard. But the National CAD Standard is going to apply more often to commercial buildings, hospitals, high-rises, those sorts of things, rather than residential design, homes and things. All right, so the spacing according to the NCS is that your first row of dimensions should be 9/16 of an inch away from the edge of the building when you print the floor plan. And then the distance between this row and this row should be at least 3/8 of an inch or 10 millimeters. And what this translates into when we make a drawing, a 3/8 inch spacing would equal 18 inches if measured in model space in an AutoCAD drawing at a scale of 1/4 inch equals 1 foot. Okay, so that would mean the distance from this dimension to this dimension in model space, we would actually want that to be 18 inches. And then when we print this at a scale of 1/4 inch equals 1 foot, that will turn out to be 3/8. And same way, we would want to space this 27 inches, the first dimension, we'd space it 27 inches away from our building. And when we scale that down to 1/4 inch equals 1 foot, that would translate to 9/16 space on our scaled down drawing. All right. So those are things that you'll have to take into consideration. So a quick review. Dimensions are placed from the outside face of framing of exterior walls. The first line of dimensions, the one closest to the window, to the structure, indicates interior walls and the centers of doors and windows. The second line of dimensions denotes the distances between outside walls and interior walls. The third line denotes the overall distance between outside walls. Interior dimensions usually locate interior walls and other features from the edges of outside walls. Dimensions should be aligned with the dimension line and read from the bottom and right side of the sheet. And so what we mean by that, if we have a dimension that runs this way, the dimension will sit on top of that like that. So there's no break in there. And so this is what we mean by when we said that the text aligns with the dimension. So if the dimension is vertical, the text is going to read vertically. Dimensions should be centered above the dimension lines. The space between the outside edge of the building and the first dimension line is 9/16 minimum, should be consistently applied throughout the drawing. So on each side of your building, you should use consistent spacing. The spacing between succeeding parallel dimension lines is 3/8 minimum, and so remember we said this would be 27 inches in model space and this would be 18 inches in model space, and it should be consistent throughout the drawing. Through all your dimensions should be consistent. Dimensions may terminate in tick marks or arrowheads, and tick marks should be parallel, which means if they're running this way, you wouldn't have a tick mark that comes through and runs like that. All right. Dimension text height should not be less than 3/32 on CAD drawings. So that's when it's printed. And it even, the NCS says 1/8 of an inch on hand drafted plans. Dimension font style should be sans serif. Now this is according to the NCS, and all notation should be capitalized, and avoid the italicized, bold, or underlined fonts if you're complying with the NCS. All right, so that is the end of the little lecturette on dimensioning architectural and the spacing and everything. All right, good luck.